In this video, we will see how formula columns in a physical table are handled in Encarta. So a very simple example, customers table, and there is a formula column, name is F1, and formula column is pretty straightforward. You can see it here. And take a look at this formula because I'm going to use SQLi and you will see what happens to this formula column when we connect to Encarta using SQLi. All this is doing is comparing customer marital status with a particular value and returning another value. All right, so let's get started. Now keep in mind one thing, anytime when you load data in Encarta, this customers table, this has 23 columns. All these columns are stored in Parquet file. In Encarta, Parquet file gets created, columns are stored there in Parquet file, but this is very important. We do not store formula column in Parquet file. We just do not store it. And this is important because when you query this table, either using MV, which is Spark, is query execution engine, or using SQLi when you connect to Encarta using Spark port, or for some reason there's a Spark fallback. This column is not there in Parquet file. Spark is only aware of data sitting in Parquet file. It doesn't know data which is loaded in memory or any formula column which is there as part of physical table. So how do we handle this? Let's look at that. Now, when you load data for the schema and for this table, let's look at this tenant name, demo was installed. So this is running locally in my laptop. Let me show you something. Let me go to this tenant here, and then what you will notice here is compacted folder. This is where I have the sales schema, and then you have customer schema. This is the only one which got updated today. I didn't load other data for other tables. And inside this Parquet file, this is the latest Parquet file I have here. Now, if I go to other folder DTM, inside this you will see schema. Then let's go to sales schema. Now you will notice here I have customers table, and then I have this f1.txt because this is the formula column I created for this particular table, and this is the file which got created which contains data about that formula column for that table. And by the way, this is 5.1, so directory structure will be different in the release before 5.1 or 5.0. Now what this means is formula column data is sitting in snapshot file, but it's not there in Parquet file. So how do we query this when we call this table using Spark, either using MV or using Spark port? So let's take a look at that also, how Encarta handles that. Now to do that, I have the SQL audit folder here. Right now it's blank, there's nothing here. I'm going to connect using SQLi and query this table using Spark and using Engine. And I will show you the query that Encarta generates to query this table. This is very interesting, so please pay close attention. Let's go to pSQL. And first I'm going to connect using engine port, which is 5436, which means query will go to Encarta engine first. Encarta engine will execute the query. For some reason, if query fails, it will go to Spark. If it does not, then engine will execute the query and send the response back. This is going to be a very simple query, so I don't expect query to go to Spark. This will always go to engine. Okay, this is my query here. Select star from sales.customer, and this is sales table, sales schema and customers table. Let's run this query. Let's change this to 15 or something so that it's not cached. There you go. You get all these columns here, and last column here is F1. Okay. Now let's go back to this SQL audit. By the way, you can load this in a table and a schema in Encarta and see all the data in Encarta dashboard as well. But I prefer looking at it like this because I'm running Encarta locally in my laptop. So you can see here a tenant name, user, receiver, and handler both are here. This is engine, and this is like new SQL engine we have introduced in 5.2. That's why it shows Nessie, but basically it's engine. This is the original query that we received from the client, and this is intermediate query. Now Encarta is converting this query into select each column name from that schema. But pay close attention to this particular column here, which is the last one, which is F1, dot F1 as F1, right? Because this is 100% Encarta engine. It is aware of that column. It sits in the engine. It's loaded in memory. So Encarta is just calling this column as F1 from that particular table. and then it shows execution time in milliseconds, number of records. Okay. Now let's do the same operation using Spark. Now keep in mind, Spark has no clue that there is a column called F1 in customers table. Actually, Spark knows that because of metadata, but that column does not exist in the Parquet file. So how will Spark handle this? This is very interesting. So let's look at this. Let's go to port 5442. Now in Encarta port 5442, this is a default port. It will always send query to Spark. It will not send query to Engine at all. It means Encarta is going to query directly from Parquet files. Now if it is querying from Parquet file and that formula column I just reviewed with you is not there in Parquet file, how will Spark query that? Let's take a look. Let me send this query here. And okay, so sometime it may take time to get the response back, but let's wait for it. So let's start from sales.customer limit 10. Let me see what happened here. Okay, now we got it. So let's look at this. We got this column F1 as well. Okay, and let's go back and look at the query now. Okay, so you can see here, receiver is Spark, handler is Spark. This is original query. Then this is intermediate query, right? And what you will notice here is what I want to show you is keep an eye on this one, this F1 here. You see here? Now this is converted into a formula which is equivalent, formula equivalent in SQL using case. So this is case when sales dot cust marital status like %married %, then married, and so on. Okay, and this is equivalent Spark query. So what Encarta is doing is it is converting this query that I sent from the client, and to read formula column as well, that formula column is translated into SQL, and then this query is sent to Spark to execute that query. Unlike Engine, where it is just select F1, it is not F1, it is the whole the formula is converted into SQL. So this is where you have to be careful. Make sure that whatever formula you are writing in the table is getting converted correctly. Sometimes there might be issues in the way formula is getting converted, so you should always review that. And by the way, if you want to see that formula in Encarta, you can do that too. Other way to do that is you can just drag and drop. Let's drag and drop this one and F1 here. And now when you click on SQL, you will see that Encarta is generating SQL here, which is more friendly to Spark than Engine. And you can see exactly similar SQL was sent to Spark as well from SQL client. So SQLi interface in Encarta is converting that formula into a SQL that Spark can understand and then return the response, because Spark doesn't know that F1 column exists in customer table. I mean, it knows via SQL, but not like the way the Engine knows. So when you convert that formula into equivalent SQL, now Spark knows that this column exists in table in Parquet file, and it uses this SQL inside this and then returns the result. So keep this in mind. It will also help you when you integrate with Tableau or Power BI, and when you query formula which does not exist in Parquet files, and for some reason there's a Spark fallback and query goes to Spark, then this formula gets converted into a complex SQL. This is a very simple formula, but many times there will be very complex formula referring to 3 or 4 other tables. There might be row level security which will convert into where clause here, and Encarta will generate a SQL for that as well. So please keep that in mind when you are doing data modeling in Encarta in respect to how Encarta handles formula column when you connect Tableau, Power BI or SQLi client to Encarta, or when you call that table from MV.